All right, so the next set of questions I feel like can be easily done through Excel. There's a very easy method using data analysis that will give you all of the answers within seconds. So before we get to that part, let's understand what this question is asking, because that's what we need for the null and alternative hypothesis. So this question is saying that the US Police Department wants to know if a new campaign to make citizens aware of drunk driving has been effective. So what they do is they count how many people have been stopped with alcohol in their body before the campaign and after the campaign. So if the campaign is effective, that means that after people watch the campaign, there are going to be less people drunk driving than before. So I'm just going to say this one more time because I know some students have a little bit of difficulty with understanding this. And it's that if the campaign has been effective, if this campaign on drunk driving has been effective, there are going to be less people drunk driving after the campaign starts than before. So what I'm going to do is I'm just going to call after mu1 and I'm going to call before mu2. So we said that if the campaign has been effective, that means there are going to be less people driving drunk after than before. That means mu1 after should be less than mu2. And what we want to do is we want to move this over. We want to move mu2 over. We want all the mu's on one side. So I'm going to subtract mu over to get mu1 minus mu2, and it's going to be less than 0, right? And for the purposes of this, since this is a differences problem, we're just going to say mu1 minus mu2 is going to equal mu of d. So these two are the same thing for this type of problem, because this is a differences problem. Okay, so mu of d is less than 0. And I said this before in one of my earlier videos that typically in these problems, we are given the alternative hypothesis. So this right here is our alternative hypothesis, so HA. And that means our null hypothesis is going to be the opposite. It's going to be mu of d, right? So opposite of less than is greater than. So we're going to do greater than. And our null hypothesis always has an equals in it. So we're going to put equals and then 0. So just from this, we can get our answer to 33. So that will be A. So I'm going to mark this here. All right. So the next set of questions, they're asking for the test statistic, critical value. Do we reject or do not reject, the p-value? So what we can do is this. Go to data, then go to data analysis, then go to t-test paired to sample for means. You can say, okay. Your variable 1 range, so I'm going to do my after. Your variable 2 range, you're going to have that as before. I included labels in mine. I included after and I included before in my range. So I'm going to make sure to have labels checked. If you start from here, from 1 and from 6, then you're not going to have labels checked. But because I included labels, I'm going to have labels checked. Our alpha, we can just quickly look down here, is 0.05. So alpha 0.05, have that there. Our output range, you can put that wherever you'd like. I'm just going to put it here. And this is where our output is going to be. So just say, okay. And here we go. All right. Now, looking at this right here, our alternative, is this a one-tailed test or a two-tailed test? So let's just really quickly try to match this up, this right here, up with our cheat sheet. So we have our alternative as less than. So that matches with this one, right? Mu of d is less than. You can see that this is a one-tailed hypothesis test, right, to the left, because it's less than. So when you look right here, we have 2 different p-values and 2 different critical values. Since this is a one-tailed test, we don't even need to look at these two-tailed results. So I'm just going to delete this to make it easier. So remove that. And all right, now we can get started looking at these questions. So 34 is asking, what is the value of the test statistic? The test statistic is right here, negative 2.05. So the answer is A. There we go. Now it's asking at alpha 0.05, what is the critical value? Now this is something that you need to be careful with. Because our alternative is less than, when our alternative is less than, our critical value has to be negative, always. In any hypothesis test problem, any chapter 9 problem, any chapter 10 problem, if your alternative is less than, your critical value has to be negative. Whenever you do this process on Excel, what we did, this t-test paired 2 sample for means, they're always going to give you a positive critical value. So it is your responsibility to look at the alternative, double check, is it greater than or less than? And if it's less than, you need to go in manually and change this to a negative. All right. So this is our answer. It's negative 1.94. So the answer would be A. See, if we didn't change it, we weren't paying attention, we would have put D, and that would have been incorrect. Okay, so we've established that our answer is A. We need to change that to negative. There we go. Number 36 is asking at alpha 0.05 and using the correct critical value, do we reject or do not reject? So we have to use the critical value test. And if you guys remember from my previous video, whenever we do the critical value approach, we need to compare the critical value with the test statistic. Those are the two numbers that we're comparing to each other. So we've established that this is what we're looking at. This is what our graph is going to look like. So let me draw this out. So this is what we have. Let me make this in red because this is our rejection region. This is green for our do not reject. And this right here is our critical value. So we've determined our critical value is negative 1.94. So let's just do negative 1.94. And our test statistic, just right here, is negative 2.05. So where is negative 2.05 in relation to this critical value? Negative 2.05 is going to be somewhere here, right? So I'm just going to put TS for test statistic. So that's this value right here. And because our test statistic lies in the rejection region, our answer is going to be reject. So, all right, here we go. Number 37 is asking what is the p-value? So we can just easily identify that right here, 0.043. So our answer is C. And that's how you do this problem. Fairly easy.